multiplexer means it's a kind of a combination circuit that we can understood because it is an example of combination circuit. And the properties of multiplexer is which is going to take 2 power n lines as input, and it is going to produce one line as output. So this is the property of multiplexer. I mean, if you are going to have a circuit like this circuit is having 2 power n lines as input, where all these lines I can call it as 2 power n lines, which is going to produce one line as output. Right? What is the advantage of this multiplexer? You may have a question, right? So the advantage is you will get very less circuit size. Meaning that if you are going to take any kind of chips, right? Those chips are going to construct with the help of this kind of gate like multiplexer, all those things, right? Instead of constructing with the help of basic gates, you are going to get very large size. So if you would like to reduce the size of the circuit, we can go for advanced version, where advanced version one of the type is multiplexer. Sir, can we able to implement the basic gate circuits with help of multiplexers? Yes, we can do. Right? That's the reason we are trying to learn one of the example of common circuit is multiplexer. Right? Basically, for example, if I am going to have two inputs, one input is 0, another input is 1, you are going to get one line as output, right? Basically, right? This one I can call it as 2 by 1 multiplexer. I will call it as 2 by 1 multiplexer, right? So meaning that here you are going to have two inputs and one output, right? Basically, if you are going to take one more kind of multiplexer, 4 by 1 multiplexer. What is the meaning of this one? It is going to have 2 square by 1 MUX. I can call it as 2 square means what? 4 inputs are there, one line as output. Right? Now, if you would like to observe here, if I want to identify these lines inequally, how many bits are required? To identify these 4 lines inequally, how many bits are required? Can I take 2 bits? If I take 2 bits as A and B, the inputs are like 0, 0, 0, 1, 1, 0, 1, 1. Am I right? So can I able to give 4 names inequally or not? Yes. So this line simply defines as 0, 0, 0, 1, 1, 0, 1, 1. Similarly, if you would like to identify these two lines inequally, how many bits are required? Only 1 bit. That's why I have taken only 0 or 1. Fine. Now, my question is here, if I am going to get 0 as input, like some certain inputs are there, how can we bypass this input to this particular location? Right? There are 2 cases are there. One is I can able to pass output as 0 or I can able to pass output as 1. How can we pass it? Right? There should be some kind of controller is required. Right? There should be some kind of controller is required. That control I will call it as select line. I will call it as select line. How many select lines are required in order to control two particular elements? Only 1. Right? Because if I are going to give 0 as input, what is the meaning of this one? I am simply calling come 0, meaning that 0 will become and it will be hand over to output side. If I call as 1 come, then what it will do? Instead of 0, it will simply call 1. And that will be as output. Right? Similarly, if you would like to have a 4 by 1 multiplexer, how many select lines needed? How many select lines are needed? 2 select lines are needed, right? So meaning that, to call them inequally, you have required some 2 select lines. One is like assume that S1 and S0. Technically I will call it as select line 0, select line 1. And this one I will call it as I0, input 0, input 1, input 2 and input 3. Output I am going to represent technically as Z. Right? Basically you can make it as Y also, but for the sake of your understanding I am taking it as Z. Right? Now, if my inputs are 0, 0, what is the output you are going to expect? I0. Right? I am simply calling please come 0, 0. 0, 0 is name for I0. So that's why I am going to get as output, right? If I am going to pass 1 0 as input, what is the meaning of 1? Please come 1 0. What is the name given to 1 0? I2. So you are going to get the output as I2, right? Like this it is going to be worked, right? So if you are able to observe, the corresponding how this 2 by 1 mux is behaving, right? So if you are going to name like this as S0, this as I0 and I1, what is the output? Z. Output is Z, right? So now can you able to construct the truth table for this? Yes. How can you construct the truth table? My name of the input select line is S0. When I am going to give the S0 as input, what is the respective output you are going to get? Right? So if you are going to give S0 as 0, what is the output you are expecting? I0. If I am going to give the input as 1, what is the output you are expecting? I1. So this one I can call it as characteristics table. I can call technical as characteristic table. Why I am going to call it as characteristic table? Which is going to define simply the characters of the multiplexer. Meaning that what are for what inputs, how it is going to behave. If I am going to give the input as 0, it is behaving and it is going to produce a I0 as output. If I am going to give 1 as input, it is going to produce I0 as I1 as output. Right? That's what I am going to say, that it's called as characteristic table. Right? From this one, if I am going to construct the equation, I can call it as characteristic equation. Right? So what is the output for Z? Z I can be written as S0 bar I0, S0 bar I0, or it may get as S1 I1. Am I right? If I am going to expect the output can be either S0 bar or I0 or S1 I1. Am I right? If I are going to give here S0 as input, here if I give 0, what is the output you are going to expect? I0. So 0 into I0. 0 means how we are going to represent S0 bar into I0. Right? So this is what I can call it as characteristic equation. From this characteristic equation, can we able to construct a circuit for it? Yes, right? So what you can do, you can simply take one AND gate. I think so this is kind of sum of products expression, right? So you have two product terms, so you require two AND gates. One is taking the input as I0, another is taking the input as I1, and I think one is going to be complemented, another is going to be direct value for S0. And both are going to be combined and they are going to be produced as one kind of output. Am I right? So that output I am going to call it as Z. Right? If you are able to cleanly observe the same circuit, I can relook like this. Right? So try to observe. I am just making the indication. As S0. Finally, I am going to combine these two and you will get like this, right? So I have written the same structure. Is it okay? Is there any problem? No, right? So now if you are able to observe, this is I0 and I1, S0, and I am getting the Z as output. If you are able to observe this circuit, is it look like a kind of a multiplexer or not? A kind of multiplexer? Yes, right? So where you are going to have two inputs, you are giving directly and it is going to produce one output based on a select line. So internally, every multiplexer contains what? Again, basic gates only. Internally, every multiplexer contains basic gates. That logic they are going to be simplified. Right? So means if you are going to have 2 by 1 mux, how many AND gates and how many OR gates and how many NOT gates are required here? According to this particular example, you require 2 AND gates, 1 NOT gate and 1 OR gate. So if you would like to implement any kind of this kind of requirement at any time, what you can do, instead of taking 2 AND gates, 1 OR gate and 1 NOT gate, you can simply take one multiplexer. That multiplexer is of size 2 by 1. Right? That is the advantage of multiplexer. Similarly, if you are able to construct the truth table for the 4 by 1 mux, 4 by 1 MUX. Assume that S1, S0 as input, or else I will try to take here only. Right? S1, S0 as input. Guys, try to make sure understood that the order in which you define the select lines, the same order you have to make the respective truth table. Otherwise, your results is going to be changed. S1, S0. What is the output you are going to expect? Z you are expecting. So when you are going to give 0, 0 as input, what you are going to get? I0, I1, I2 and I3. The same thing you can able to write it as Z as S1 bar, S0 bar into I0, S1 bar, S0 into I1, S1, S0 bar, I2, S1, S2, I3. This is what I can call it as characteristic equation. From this one, you can able to draw the corresponding circuit diagram. Corresponding circuit diagram, which is of type 4 by 1 multiplex, like this, right? So if I am trying to say that 8 by 1 MUX, 8 by 1 MUX, how many inputs are there? How many inputs I am asking? 8 inputs are there. 3, 6 and 8 inputs are there. How many select lines are required? 3 select lines are required, and you are going to produce 1 as output. Right? This is what I can call it as 8 by 1 MUX. So which can range from I0 to I7, and I am going to make it as S1, sorry, S2, S1, S0. You are going to get produce output as J. Right? Fine. See, I said already. So the advantage of this multiplexer is we can able to reduce its size. We can able to reduce its size, right? But here the question is, can we able to implement any kind of Boolean equation or not? See, if I am going to have any kind of Boolean equation is in the form of sum of the products, then I can able to construct it with the help of AND OR gates. AND OR gates, am I right? Yes, I can able to construct AND OR gate, right? If I am going to construct AND OR gate, can we able to construct with the help of product of sums? Yes or no? You know the standard sum of the products, standard products of the sums. Once you know the idea of standard sum of the products, we can able to convert it into standard product of the sums, so that you can able to connect with the help of OR AND gates also. So if you are going to have product of the sums, you can able to construct OR AND gate. Once you construct AND OR gate, can we able to construct with the help of NAND gates? Yes. If you are going to have product of the sums, can we able to construct with the help of NOR gates? Yes or no? Yes. So the reason why we are moving from AND OR gates to NAND gates is to make them they don't know exactly how many kind of exact basic gates are required to implement, right? How many AND gates are required, how many OR gates are required, that they don't know exactly. That's the reason if you are able to try to implement with the help of same circuit, same basic gate like NAND, so that they don't want to bother about how many NAND gates are required. That's the reason we try to convert AND OR gates into NAND gates. Similarly, the same problem arises for OR AND gate also. That's the reason we come across with the help of solution called NOR gates. But here the thing is, if you are going to have a Boolean equation, can we able to implement with the help of 2 by 1 MUX? Okay, fine. Or for example, if you would like to implement with the help of 8 by 1 MUX, I can able to implement. But if I would like to implement with the help of 2 by 1 MUX, is it possible? That's the question, right? Or else, whatever the equations that are possible in NAND or AND OR, can we be able to implement all the things in using the multiplexers? The answer is yes. Yes, no. Why? Right? So, guys, for example, here, why I am saying that AND OR gates I can able to implement with the help of any other gates? The reason is this AND along with any kind of NOT gate is a kind of functionally complete. What is the meaning of functionally complete? I can able to derive any kind of Boolean expression. If I have the terms like OR and NOT, I can able to derive any kind of expression. Then I can call these two as functionally complete. Guys, in SQL or in relational algebra, you come across the terminology called set complete operations. Set complete operators. What are the various kind of set complete operators? Right? It will be a collection of some kind of operators. One is select, project, minus, join operation. Join operation, right? Meaning that with the help of those four, I can able to construct any other kind of like equation. That's the reason I am going to call it set complete operation. Similarly, functionally complete means whatever the functions we are going to construct, those functions, if you are able to construct with the help of plus and not, I can able to construct with the help of I can able to construct any other kind of Boolean equation. Similarly, or if I am going to have and not, this also I can call it as functionally complete. Functionally complete, right? If I say that plus or and not, can I call this as functionally complete? Right? These two are independently functionally complete. If I am going to combine, I can call it as functionally complete. See, for example, I am going to have A and B with OR gate. A and B with OR gate. This is what I require. This is what I require. And I am going to have only dot and not operators are there. Dot and not operators are there. Can I able to construct that? Can I able to construct? Try to observe. Can I make use of A bar dot B bar whole bar? De Morgan's law, right? Means can I call now this and not are functionally complete for this OR operator or not? Right? Once you got OR operator, can we able to get again NOR gate? Yes or no? For this, what you can do? You can make some kind of complement. A plus B whole complement. This is what I can call it NOR gate. From this, can you able to get AND gate? Yes. So and so on. Means once you know, once you have the inputs like and not, you can able to get all kind of other kind of operators, gates. That's what I can call as functional complete. Similarly, if you are going to take A plus B, or if you would like to get A and B, can we able to get A and B with the help of plus and not gates? Right? So these two are complement. I think it is correct. Right? According to De Morgan's law. So I can call this also functionally complete. Functionally complete, right? So means if I am going to have simply a plus and like or and not, or and not, or combination of all these, I can able to derive any kind of expression. That's why I am going to call it as a functionally complete. That's why we can able to construct any kind of circuits there. Right? Now the question is, can we able to do like this or not? Right? If I am able to say yes, if I am able to say yes, I need to prove that I can able to get all kind of like NOT gate, AND gate, or OR gate, NAND gate, NOR gate, XOR gate, and XNOR gate. If I am able to get all these from one kind of like multiplier, can I say that it is functionally complete? It is functionally complete? Yes. So here, to make prove that, so I can say that multiplexer is a kind of functionally complete. That is the advantage. Multiplexer is functionally complete. That's the reason we can able to construct any kind of circuit. So that's the reason I am trying to do this example. So try to do. Let me have a 2x1 multiplexer. 2x1 multiplexer. If I say that it is 2x1 multiplexer, what are the inputs are there here? It should be S0, it should be Z, and it should be I0 and I1. I0, I1, right? Now, if I am going to give an input like X, I need to get the output as for NOT gate, X bar. How can we get? If I am going to give input as X, how can we get X bar? So that I can say that multiplexer will act as a NOT gate. So observe in the equation, what is the equation we are going to get, ma? Basically S0 bar I0 plus S0 into I1. S0 into I1, right? Try to substitute. This will be x bar into I naught plus x into I1. Right? From this equation, can we able to get the x bar? How can we get the x bar? If I am going to place I naught as 1, I1 as 0, I1 as 0, what is the expression you are going to get? X bar. So are you going to get the x bar or not? So now, what are the inputs should be for I naught? Input is 1 and this input is 0. Can this circuit will act as a NOT gate? Yes or no? So this way you can able to make your multiplexer as NOT gate. Right? Similarly, for example, if I are going to have AND gate, how we are going to prove that AND gate is can we able to achieve it with help of multiplexer? Means AND gate requires how many inputs? How many select lines? 2 select lines are there. If I am going to have 2 select lines, how many inputs are there? 4 inputs. I need to have 4 by 1 MUX. 4 by 1 MUX, right? Now, this should be I naught, I1, I2 and I3. Now, in order to get the input, like for example, if I am going to pass an input like x and y, what is the output I require? xy I need. xy I need, right? So now what you can do? Right? If you are able to construct the truth table for this, like S1, S0, it's look like this: 0, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1. Means this are the inputs. These are the input, right? Means the inputs are like 0, 0, 0 and 1. If I am going to pass 3 zeros followed by 1, if I am going to here pass one value as 1, 0, what is the select line it is going to select? I2. I2 select chesindante, what you are going to get? 0. Is it correct or not? For 1, 0, output is 0. So that's why if you are going to pass 1, 0 as input, it's going to be selected this line and its line will be it will be connected like this, right? Then you are going to get a 0 as output. So I can say that it is AND gate. Right? So here you may get question, right? So can we able to implement the same thing with the help of 2 by 1 MUX? Right? When you have seen the concept of variable entrant map, I have explained how to minimize the K map. Right? So if you are able to observe here, if I try to combine these two. So if you are able to observe, like in 2 by 1 MUX, how many select lines are there? Only one select line is there, S0, and input lines are 2, I0 and I1. Right? Now, how can we convert the same properties to 4 by 1 MUX to 2 by 1 MUX? 2 by 1 MUX, right? If you are able to observe here, now let me consider for timing, I will try to construct it for I1 so that it is easy for you. If I take it as S1, S1 for inputs S1 0 0, what are the its respective outputs? What is respective outputs? 0, right? Means I can directly write it as 0. For the inputs 1 1, what is the output you are expecting? Which is same as S0. So can I write like here as S0? Now observe. So the inputs here are, when you are going to pass 0 as input, I0 should be selected. I0 value is 0. And for I1, the input is S0. Right? Then you are going to get the respective output. This is the way you can able to reduce. Right? So here the inputs are changing. Input is 0 here. Input is S0. Here the input is S1. Right? If you want, you can check. Right? For example, if I am going to give the input like as 1 0, S1 is 1, S0 is 0. 1 will be here and 0 is here. Right? If I am going to pass 1 0, as I am getting the 1 as input, what is the select line is going to be selected? I1. What is the value of I1? 0. So this way it is going to be debugged. Okay. Similarly, if you are going to do with help of, so I can call this as NOT gate. and AND gate. If you take OR gate, like you can able to do directly, right? 4/1 MUX OR gate. So what are the inputs are possible for OR gate? 0, 1, 1, 1, and this will be like S1, S0. This will be J. This is 4/1 MUX because I can able to directly analyze according to the table. Can we able to do it with help of 2/1 MUX? 2/1 MUX. What you can do? Right. Basically, if you are able to observe in 2/1 MUX also, if you are going to have, so what is the output you are expecting here in 2/1 MUX for OR gate? For OR gate, the results will be like 0, 1, 1, 1, 0, 1, 1, 1, right? If I am going to have 0 as input, what is the output you are expecting? S0. If I am going to have 1 as input, what is the output you are expecting? 1, 1. So here, one input is S0, first one is input is S0, and second input is 1 when the input select line is S1. Right? It's going to produce its corresponding J. Guys, is it always necessary to select S1 as the select line? No. Means here the same thing I can be rewritten as like this. If I am going to have 2/1 MUX, this is I0, I1, and this can be S0 also. See, earlier I have taken this as S1. Now what I did, I have taken it as S1, S0. If I take it as S0, what you have to combine? This 0 and this 0 you have to combine. When 0, 0 as input, what is the corresponding output you are expecting? 0 only. 0 only, meaning that irrespective of the S1, you are getting again 0. Again 0. Right? What about the 1? If you are going to have the 1, 1 as input, it is look like 0, 1, the 0, 1, same output. So it will be getting as S1. Right? So now I0 is 0, I1 is S1. Similarly, means these two are now equivalent. This one and this one, these two are equivalent. Is it okay? Yes. Now, can you able to define for this? What is the equivalent for this 2/1 MUX OR gate? Can I write right? This is S1, this is 1, this is S0. According to the previous and another kind of multiplexer.